Hello, and welcome to our lesson on rounding numbers. Today, we will explore an essential concept that will help you make mathematical approximations and streamline your calculations. In this lesson, we'll deepen our understanding of number approximations by learning how to round numbers to a specified amount. We will start by defining what it means to round a number and why it is useful. We'll then explore the different rules for rounding depending on the position of the digit in question, such as units, tenths, hundredths, etc. Lastly, we will run through some examples to apply this new knowledge, ensuring that you feel confident in rounding numbers correctly. In our previous lessons, we've laid a strong foundation by discussing number placement and values, understanding the positional value of digits within a number, such as the units, tens and hundreds, etc. Secondly, we've covered estimations and using estimation techniques to approximate the results of various calculations. With these mathematical tools, you'll be well equipped to handle various scenarios where approximations are necessary. Let's dive in and enhance your ability to round numbers effectively. Firstly, let's define a decimal. A decimal point separates the whole number part from the fractional part of a number. Rounding to decimal places helps us to refine data to a specified level of precision. Let's look at an example. Round 3.14159, or pi to 3 decimal places. First, identify the decimal place to which you need to round. Here, this is 3 decimal places. We refer to this as our target digit. Then, examine the digit immediately to the right of the target digit. Here, this is the 4th place, a 5. If this digit is 5 or greater, we round up the target digit. So here, our 3rd place target digit changes from 1 to 2. If it is less than 5, we leave the target digit unchanged. Therefore, 3.14159, rounded to 3 decimal places is 3.142. Now let's try rounding to significant figures instead. Significant figures are the digits in a number that contribute to its precision. A significant figure is any non-zero value as well as zero values that follow after a non-zero value. For example, the zeros in 0.00 are not significant because they do not come after a non-zero value. However, the zeros in 100 are significant figures since they come after the non-zero value of 1. Significant figures are particularly useful for scientific notation and precision when making measurements. Here, let's round 0.004567, to 2 significant figures. First, we must identify the first non-zero digit, which in this case is 4. Then we count the desired number of significant figures, starting from this digit. We want 2 significant figures, so in this case these are 4 and 5. Look at the next digit. For us, this is the 3rd digit, which is 6. If this digit is 5 or greater, then we round up the last significant figure. So here, our 5 changes to 6. If it is less than 5, then we leave it unchanged. Therefore, 0.004567 rounded to 2 significant figures is 0.0046. Now, let's review rounding to the nearest whole number. Whole numbers are numbers without fractional or decimal parts. Rounding to whole numbers simplifies numbers for everyday contexts such as counting, pricing, and more. Let's round 7.85, to the nearest whole number. First, we must identify the digit in the tenths place. In this case, ours is 8. Then, if this digit is 5 or greater, we round up the unit place. Here, our 7 becomes 8. If the tenths place is less than 5, then we leave the units part unchanged. Therefore, 7.85, rounded to the nearest whole number, is 8. Great! Now let's try some more examples. Let's first look at this question, round 47 to the nearest 10. To answer this, we need to identify the digit in the tens place, which in this case is 4. Then, we look at the digit in the units place, which is 7. Finally, we apply the rounding rule. The digit is greater than 5, so we round up. Therefore, 47 rounded to the nearest 10 is 50. Now, in our second example, we have to round 7.38 to the nearest whole number. First, identify the digit in the unit's place. For 7.38, the digit in the unit's place is 7. Look at the digit in the tenths place. The digit in the tenths place is 3. If the tenths digit is 5 or more, we round up. If it is less than 5, we round down. Since 3 is less than 5, we round down. Therefore, 7.38 rounded to the nearest whole number is 7. Finally, let's round 12.347 to the nearest hundredth. Here, the digit in the hundredths place is 4, and the digit in the thousandths place is 7. Since 7 is greater than 5, we round up. Therefore, 12.347 rounded to the nearest hundredth is 12.35. With practice, you'll become more comfortable and efficient in rounding numbers to any specified amount. In today's lesson, we explored the essential skill of rounding numbers, which is a key component in making mathematical approximations and simplifying calculations. We delved into 3 primary techniques for rounding: to decimal points, to significant figures, and to the nearest whole number. For rounding to decimal points, we learned to identify the target digit, examine the digit immediately to its right, and apply the rounding rule. Next, we tackled rounding to significant figures, which involves identifying the first non-zero digit, counting the desired significant figures, and rounding based on the subsequent digit. Finally, we covered rounding to the nearest whole number by focusing on the tenths place and applying the rule to round up or leave the number unchanged. By mastering these rounding techniques, you are now better equipped to handle approximations confidently in both academic and real-life contexts. Watch the rest of the GCSE Maths course at Sophos Education.